What are geometric nets and their uses in geometry? Have you ever wondered how we can take a three-dimensional shape and visualize it into dimensions? That's where geometric nets come into play. A geometric net is a flat pattern that can be folded to create a three-dimensional shape. Think of it as the unfolded version of a solid, showing all its faces laid out in a way that can be easily folded back into the original form. For example, the net of a cube consists of 6 squares connected together. When folded, these squares form the 6 faces of the cube. This concept is not just fun, it plays a significant role in geometry. Geometric nets help us visualize and understand three-dimensional shapes by breaking them down into simpler, flat parts. This makes it easier to study properties like surface area and volume. Now, let's connect this to prisms and surface area calculations. When you lay out all the faces of a prism as a net, you can calculate the surface area by finding the area of each face and adding them together. This approach simplifies the calculation process. Instead of tackling a three-dimensional problem, you can work with a series of two-dimensional shapes. Different solids have unique nets. For instance, a rectangular prism has 6 rectangles in its net, while a triangular prism includes 2 triangles and 3 rectangles. A cylinder's net consists of 2 circles and 1 rectangle. Understanding these nets helps us visualize how shapes fit together and solve problems related to volume and surface area. Geometric nets are widely used in education to teach spatial reasoning. They are also practical in real-world applications, such as packaging design. Flat patterns are often folded into boxes or containers, making nets essential in various industries. In summary, geometric nets are flat layouts of three-dimensional shapes that allow us to better understand and calculate properties like surface area. They bridge the gap between two-dimensional and three-dimensional geometry, making key concepts about shapes and solids easier to grasp. So next time you see a three-dimensional shape, remember that it has a flat counterpart waiting to be folded.